Hello, class. It's Lydia Gunn again, and today we are going to be speaking on Chapter 7. Chapter 7 is a very short chapter, and what we're going to do today is about interest rate and present value. So interest rate is everywhere. If you drive up to a bank or you pass by a bank, you see the interest rate and basically what you see being advertised on the bulletin board of the banks, any given banks, these are known as a nominal interest rate, not the real interest rate. So remember last week or last lecture or previous lecture, we talked about nominal versus real values. I think we were talking about GDP, how you deflate GDP by taking into account inflation. That is, you will take the nominal GDP value divided by the consumer price index to derive at the real value. And that's kind of important because we all know that inflation erodes the value of the dollar. So, and even in today's society, if inflation goes up, the employees, people like you and me, should talk to our boss, about the possibility of increasing our wages, because inflation has gone up, and that's actually known as indexing. Well, that's another thing, and what they do that they incorporate that COLA, the cost of living adjustment index. If you remember what we were talking about last lecture. Okay, so again, the real interest rate versus nominal interest rate. The difference between the two is the real interest rate take into account inflation. And everybody know what interest rate is because some of you take out student loans. Some of you may, most of us take out mortgages. You owe the banks money to pay for your homes, and some of you may have car loans, computer loans, home improvement loans, and what have you. So let's look at what is the market for money. So again, we go back to basic demand and supply curve, except in this case we're applying to demand for money, and this is the supply for money, and we are looking at the money market. Okay, so on your y-axis, remember we talked about that before, that's your value, and in this case we're going to say it's your interest rate. Interest rate is also considered as a value. And then here it's your money stock, M, or your so-called money stock. The amount of money that you have, that is. Okay, so the important thing is an intersection of supply and demand curve for the money. There's a demand for money, downward sloping, supply of money, as usual, is upward sloping. So you got your equilibrium interest rate. So the star usually means equilibrium. And you cannot use the term equilibrium, as you have seen in earlier chapter, the chapter on supply and demand curve, unless you're talking about there is intersection of both buyers and sellers, demand and supply. So down here you would have the, it should be dollar money. Yeah, there's an MD. So this is actually dollar money. Yeah. In other words, money stock in terms of the values. Okay. So basically that's what it is in the money market, that we deal with interest rate. Interest rate is the value of its own price for the money. Because what is the value of the money? The value of the money today is not the same as the value of money tomorrow. Or if you like, 5 years from now, 10 years from now, 30 years from now. So therefore, when you take out mortgages and loans, they usually factor in that interest rate right there. So let's look at that now. Ooh, that looks bad. But that's all right. So let's look at what is present value. Let me write it down here. This equation here. So your present value, we're going to look at, instead of looking at PowerPoint slides, we could do that, but I'm also going to rely heavily on the book because the book has several tables that we could refer to today. So this is, present value is your payment or future payment divided by the 1 plus r raised to the power n. And so your r will be your interest rate. Where is interest rate of 1%, 5%, 10%, 20%, for example, which is extremely high, and n stands for the numbers of years. So basically what we're saying is that money today is not the same as money tomorrow, because if I give you $1 today, you know, are you going to accept it, or, you know, are you going to wait 10 years to for the money to grow, you know, put it in the bank? And so we're going to look at what this value will be. Although, you know, $1 seems like it's not much, but if you increase it to, say, 1,000 or 10,000, then you start to see the difference. Even $1 with a high interest rate over a period of time, it makes a big difference to you. So I'm going to give you an example here. So for that, I would like for you to refer to your textbook. Okay, I'm looking at your textbook here. So if you would look at table, I believe is 7.1. Yeah, your table is 7.1, where you have the rows of the rows that represent the interest rate, and then the columns that represent the number of years that you would take out the loans, for example. So I'm going to give you a couple of examples here so you understand how to apply it. Okay, so the first example that we're going to look at, so let me rewrite this. So let's write PV equals to payment, that will be your M. Let's use a short form here. So PV equals to your payment, I'm going to write M because that would be in terms of money stock. So, but basically it's the same thing. So it's just easier to work with. So in other words, you could rewrite this equation. So your payment, like how many payments you have to make, you know, every month for the next 2 years or 5 years or 10 years. So if you rewrite the equation, this becomes your present value multiplied by 1 plus r raised to the power n. Okay, I hope you could see that. So let's give one example. For example, according to that table 7.2, I believe, yeah. So it says that if you borrow $1 today, okay, I mean, this is this example, although I don't know anybody would want to borrow $1 from anybody. So if you borrow $1 today and then you promise to pay it back in 5 years at 5% interest rate, and what would you owe at the end of that 5 years? And so let's work on that. So if you do that, what I do is you would plug in. So you want to look at how much that future payment will be. You know, after 5 years, 5% interest rate if you put in a bank. So then what we do is your present value will be $1 because if you invest in $1 today, and your interest rate, like I say, is 5% in this example. So this would be 0.05 raised to the power n, and let's look at 5 years. So there it is. So this would become 1 multiplied by 1.05 raised to the power of 5. So if you use your financial calculator using the exponential function, you should get the answer to be 1.2762, or approximately $1.28. So what does that tell you? So that tells you that, okay, you would actually get 28 cents of interest. So in other words, that you would actually get at the end of 5 years, $1.28. So that 28 cents is essentially the interest payment to you for putting that $1 in the bank. Okay, so you look at this example, you say, well, okay, this is a very simple example, and in reality, nobody put $1 in the bank and hope to earn 28 cents interest payment, because that's seems like it's so minimal. Okay, well, let's look at the same dollar amount, but let's extend that to a higher percentage, like 20%, and then let's go for longer years, like 30 years. So there it is, the second example. This is example 1. Here's example 2. So we're going to use the same formula, AM. Again, AM stands for future payment. What do you get, 5 years from now? What do you get 30 years from now? So like I said, we would apply the same equation, but now instead of 5%, we want to do, 20%. So that would be 0.20. So remember, for this kind of calculation, you cannot, if it is 20%, you have to convert it to decimal places first. You cannot just put 1 plus 20, which is 21%, So you have to put 0.20 for 20% and 0.05 for 5%. Okay, so that's what you got, and then you're going to raise it to 30 years, because you want to look at now that dollar after 30 years with 20% of interest, how much will I get in the future? Okay, so if you do that, so once again you have 1, and then 1.2 raised to the power of 30, and if you use a financial calculator to calculate that, the answer should be around $237.38. Wow. How about that? So I mean, imagine that's just $1. That if it is $100, that would be a lot more. And if it is $1,000, that would be a lot more. So that's how you calculate it. And so most of us have experience, like I say, taking out mortgages and taking out loans, and you make multiple payments, not just one time pay it off, So that's how you would do it, like how many years. So that's the number of years that you raise it to the power of 30 years versus 5 years. And then the interest rate is in that little r there. It's your interest rate right there. So don't get confused, because as you can see, right, this amount should be a small amount, and then you multiply by a factor that's higher than 1, so you should get an amount that's higher than the original value, your present value. So otherwise, who wants to do investment? Your investment principal has to be lower, and then in the future you get more. So that works the same for paying out loans to the bank or any kind of loans. How much you owe, what is your monthly payment, for example, for your mortgages. And of course, that includes interest rate as well. But then, that goes to the bank. That doesn't come to you, because you pay the bank, you pay up, you are supposed to pay up your mortgages, right, until you pay it off altogether. So that interest payment goes to the bank. Hopefully the interest rate is not so high, right? Okay, so now if you look at car loans, it's not the same as paying for a house. You could extend paying for a house a maximum of, I think, about 30 years, but with car loans, it's not as considered as a big ticket item as compared to houses. So you could usually pay it up within 6 years. That's typically the most car company will loan you for about 5 to 6 years maximum. So now the next example that we would like to look at is known as multi-year analysis. So some of you are thinking about doing business. So then you want to evaluate if your business is profitable, and how many years would you have to invest in the business in order for your business to finally, make profit. So a lot of time at the beginning, the first few years, you're making losses. It's common. Look at Amazon.com. When they first started, the first few years, they were making losses. But that doesn't mean that they should quit and get out from the business. They keep persist on. That's common. I mean, you're learning how to do business. There is a learning curve involved. But once you cross that learning curve, look what happened now. They're making big profits now today. Okay, so let's look at your table 7.2. A while ago we were looking at 7.1. Now table 7.2, this is a big table here I'm trying to show you here. So we're going to look at this example here. So if you have your book with you, take it out and refer to it when I'm talking, so you have some idea what I'm talking about here. So now, the next thing that we want to look at, right, if you, once again, refer to your table there, we say we want to invest the first two columns, as you could see here. You want to make a decision whether the business investment is profitable or not. So we're using this cost-benefit principle. Let me erase that. So there are two terms that I should introduce, and that is present value cost versus present value benefit. So we want to kind of like look at these two values and see how do they compare, And if they're equal, there's a term for it in your book. Well, that basically means, you break even to some extent. So that's called internal rate of return. Is when your present value of the cost of doing business is exactly equal to your present value of the benefit of doing that business that you have. So if you look at that, once again, table 7.2, the examples say that if you invest $100 each year for the first 5 years, and you could see that this is a cost, this goes into the column number 2, which is your present value cost. And your cost is actually, so a lot of time you want to find out if this is equal or not, okay? Now when they're equal is meaning that we'll call it internal rate of return. But a lot of time they're not equal. It's either the cost greater than the benefit or vice versa. So now in the first example that we want to look at, at 5% what happened. Okay, that would be your column 1, 2, 3. Not counting the number of yearly. So yeah, that should be the first 4 columns there. So as you can see, the first 5 years you're making, you have a present value cost of $500 because you invest $100 every year for the first 5 years. And then beginning from a 6th year onward, you have a return payment of $100 per year for the next 7 years. So if you add that all up together, you have $500 versus, so your PV cost is $500 for the first 5 years, and then your PV for your benefit is $700 for the next, from 6 years onward, for the next 7 years. So that adds up to be $700. So as you can see, the benefit, this is your present value of the benefit, is greater than your present value of the cost. So I'm going to put a smiling face here, so that's nice, that's good. So we say yes, And then we say, how about we look at 2 other interest rates? How about if we look at 8%? So again, once again, if you refer to your table 2, that would be your 1, 2, 3, 4, 5, 6, Okay. Okay, let me back up a little bit. So this is talking about the cost and the benefit or investing the dollar in. But if you calculate the present value of the cost at 5%, let me go back to I don't have my book with me, but so you could see that at the first $100, right, you have the present value cost of $100 for the first year, and then $95.24 for the second year, and then so on and so forth. And then after that, it becomes your present value of the benefit. It just seems like from the first year to that last year, the 12th year, the number goes down. But so you calculate all this. You calculate the first 5 years. So this number should be, because you want to look at the present value of the cost and benefit. So please, my apologies on that. So this should be 454.60 cents. And this is 476.05. So they kind of like very close together, the present value. So like I say, if they're equal, then that's your internal rate of return. But when you're calculating, you don't know. But you use the same principle that I showed you earlier, the present value formula, to derive at these two columns. In your textbook, that will be 1, 2, 3, 4, 5, 6. That will be your fifth and the sixth column. So, and then you add up the first 5 years and the next 7 years. You get the present value cost of 454. And then present value benefit of 476. So the benefit is higher than the cost. So same outcome. So yes, smiling face, you're doing well. You're making a profit. However, at year, if it is at 8%, so we're going to go ahead and calculate 2 more. Your present value cost will be, using the same method, $331.21. And then your benefit is only $382.68. Ooh, so now this is greater. So that means your present value cost is now greater than the present value of the benefit of doing business, if it is at 8%. So interest rates are very important. So this is not so good. I'm going to draw a sad face here. And then further on let's do one more step at 10%. Again, look at the last 2 columns of your table 7.2. You will see that we got worse, $416.99, which is greater than the 332.52. Again, this is a sad face because your present value of the cost is greater than the present value of your benefit. So this 2 no good. This one yes. So and then you would say so exactly which point is when you maximize your profit. So that will be if this is exactly equal. As you can see, this is pretty close. There's 2 numbers here, somewhere around $20 difference. So this is where we want to achieve. This is our target. So if you read the book here, and it turns out that in this particular example, when you hit the internal rate of return exactly is when you have 5.8%. So this is an optimal interest rate in which you would be most profitable, because that's when your present value of your benefit is exactly equal to your present value of your cost. Okay, so the next thing that, and then I got a couple more examples, and then that will be the end of this chapter really, because this is a very short chapter. The other thing that I want to show you, so once again go back to that. Let's do one more example on the same thing that we saw earlier. So the other equation that you could use is future value. So the same thing, your future value, very similar to your present value, but you're looking at future now. You're looking forward, to the future. This will be your payment times 1 plus R raised to the power n. So really it's very similar, but it works backward because you could rewrite that equation to say what is your current payment now. So this will be your current payment. If you want to do an investment, okay, you want to find out like, okay, so 30 years later, how much is this going to be? So the example given in your book says, well, let's just say you have a baby, a new baby. So you want to invest into the baby's life and, college education, for example. So what you do is you will put in a CD, certificate of deposit of 10,000 today. So that's kind of like your present value. And so let's say the interest rate is 4%. So then this is the 1.04. And when the baby grows up and finally go to college, that's 18 years later. So then we say, how much is this payment? So if you use your calculator to calculate that, turns out that payment is going to be at $20,258.17. So doubles. A little bit more than doubles, really, but pretty close. So this will give you some idea. Like, if this is the amount of money you have today and you want to invest, so what happened like 18 years later? How much would I have to provide for his or her college education? And we tell you that assuming the interest rate is 4%. A lot of the time we do not know the interest rate. So we can only play out a scenario, what if it is 4%, what if it is 5%, and then we know how much we will rip into the future. So at least, when the baby grows up at the college entrance age, it's got that amount of money. And of course that depends on the interest rate. That also depends on the principal that you put in, or the current payment that you want to put in to invest in a child's college education. So speaking about college education, the application of some of the economic issues such as college education, why is it so expensive? So the next thing I want to look at the end of that chapter 7, it mentioned something called Rule 72. This is a very interesting rule. I'm not sure if some of you may have heard about it. This is before the computers day and calculators days. So this financial advisor, usually they use this particular rule. It's called Rule 72. So what it is if you look at your book, that last paragraph, they say, the example given is, how long would it take to double your money at 4% interest rate? So using the same example here. So in this case, it says, so what you have to do is you take 72, divide by the interest rate, which in this case is 4%, and you could divide by 4, and you actually will get exactly 18 years. So what this is saying is that how long does it take for your money to double? So if you use Rule 72, how long does it take to double the value? Okay, so that's the main question you ask when you apply this rule. And so you want to see when would it double if you put in 10,000 now. Okay, so you take 72 divided by the interest rate. So then you get 18 years. So 18 years is the answer. So you can refer to your book on that. And then there are a few definitions that's kind of like straightforward that pertain to what is exactly is risk. The various kind of risk that we're talking about in this chapter 1 is called default risk. Have you ever loaned money to somebody and then you're wondering like if they are ever going to pay you back? Yeah, some people don't return the money to you. They take the money and then you can't find them, 10 years later or 5 years down the road. So that's called default risk. And then the other one is known as market risk. And I think most of us are familiar with it. A market risk would be like, for example, we had September 11, 2001. So that's not a very good period of time in U.S. economic history, because September 11 basically plunged the economy into recession. And before that, we have internet technological stocks, the prices came down, and we have something known as internet bubbles. And the bubbles actually burst, right? Because all the internet technological stocks were overvalued. So that's another market risk. And then, of course, the Great Recession, 2007 to 2009, that's considered market risk. Any shocks that unexpected and happen suddenly, we call that your market risk. And I think in any economies you face that anyway. So the other one is known as risk premium. Well, if you do some kind of investment, like whether it's mutual funds or anything like that, that's the kind of reward that you receive for taking a greater risk. For example, if you invest in natural resources like natural gas, well, not quite natural gas, right? Oil, anything to do with crude oil, anything to do with gold, precious metals, they are very, very volatile, because I have a few investments in that area, so I know what I'm talking about. Natural resources, especially, so it's high risk, but then the return is high when you get it, but then you could be at the mercy of big loss, or you could be earning big gain there, so there's a risk involved there. So I think that's all I will talk about for Chapter 7, so thank you. The next chapter I'll look at is Chapter 8.